Now that we have spent some time adding integers using models and number lines, we're going to spend time sort of looking at how that actually ties into the algorithm for adding integers using the integer rules. So to just go back and review, one of the ways we looked at this was with models. Chip models is what I call them. And what you can hopefully see, hopefully you started to see some patterns with this. What we're really doing when we do this is we're looking at a problem like this, 5 plus negative 8, for example. Because the signs of those two numbers are different, one of them is a positive and one of them is a negative, all we're really doing is we're wanting to say, well, which do we have more of, positives or negatives? In this case, we have more negatives because we have 8 negatives and only 5 positives. How many more do we have? 3. So our answer is negative 3 because there's 3 more negatives than there are positives. In this example, negative 2 plus 7, when we look at this one, there were 2 negatives and 7 positives. So on this one, there were 5 more positives than negatives. Therefore, our answer was positive 5. Now we had some like this, negative 4 plus negative 2. When we looked at this one, we didn't have positives and negatives. We only had negatives. So those we could truly just combine. 4 negatives and 2 negatives gives us a total of 6 negatives. Now that should tie in pretty easily to our actual rules for adding integers. So our rules for adding integers is if the signs are the same, you simply add the two numbers and you keep whatever the sign was of the two numbers. So you add, really what you're adding is the absolute values. So for example, negative 3 plus negative 5 is going to equal negative 8 because you have 3 negatives and 5 negatives. Altogether, that means you have 8 negatives. The signs are the same. They're both negatives, so you just add 3 and 5 and keep the negative because they were negatives. Positive 7 plus 2, those are both positive numbers, so 7 plus 2 is 9, and it's going to be a positive 9 because both numbers were positive. If, however, both numbers you had different signs, one negative and one positive, what you do then is you subtract. And technically what you're subtracting is the absolute values of the two numbers. So you subtract the absolute values and keep the sign of the number with the greatest absolute value. So, for example, negative 3 plus 5 would be 2. And the reason it would be 2 would be because if you think about it, if we did a model of that, we would have 3 negatives, 1, 2, 3, and 5 positives, 1, 2, 3, 4, 5. So this would cancel, leaving us with 2 positives, or positive 2. Another way of looking at that, like I say, to look at it without a model is to say, well, if we have 3 negatives and 5 positives, then we have 2 more positives than negatives. Therefore, my answer is positive 2. So really what I did was 5 minus 3 is 2, and it's going to be positive because the absolute value of 5 is greater than the absolute value of 3. Therefore, we keep the sign that's with the 5. The next one, 4 plus negative 15. For this one, I could draw it out, but I'm starting to get some, I'd have to have 15 negatives. That's a lot. So this is where this rule starts to really help us. So if you think about that, if you were to draw out 4 positives and 15 negatives, hopefully you see that we're going to have 4 negatives and 4 positives canceling each other out, leaving us with 11 negatives. Or in other words, there are 11 more negatives than positives. That's why my answer is negative 11. If I look at it thinking about the rule, since the absolute value of 4 is 4 and the absolute value of negative 15 is 15, then negative 15 has the greater absolute value. So do 15 minus 4, which is 11, and keep the negative because it was with the 15, which has the greater absolute value. So negative 11. Here's a couple more examples. 7 plus negative 2, again, we're going to do 7 minus 2 because 7 has the greater absolute value. 7 minus 2 is 5, and we keep the sign that's with the 7, which is positive, so positive 5. Negative 8 plus 6. We have different signs, so we're going to subtract the absolute values. 8 minus 6 is 2, and it's going to be negative 2 because 8 has the greater absolute value, and it's a negative 8. So we keep the negative symbol that's with it. So take a moment now and let's try a few problems. Try these 7 problems. If you have to draw a picture, you can, but try to do it without the picture if you can. Pause while you try them, and then when you're done, go to the next slide and see if you have them, or hit play rather, and see if you have them correct. All right, so take a look. If there are any that you missed, go back and try them again. Use a model if you need to, but then try to tie that in with these rules and see if you can figure out where you made your mistake. So again, if you can use models, you can use number lines, but as you do that, you should be starting to see this rule that when the signs are the same, you add and keep the sign. When the signs are different, you're going to simply find the difference of the absolute values and keep the sign of the number with the greater absolute value.